Okay, so this is where we're picking up today. The Great Pyramid of Giza.
All about any construction.
It's one of the 7 wonders of the world.
What's all other
Egyptian
7?
pyramids.
What's
Okay?
the other 7?
What's that?
What are the other 7?
Oh, I don't know off the top of my head. I didn't look them up. Okay? Yeah, I think Niagara Falls. Okay. So, what we want to find here is the surface area of this pyramid. Okay, that's really what we're focused on here. So, I've given you a diagram of just a blank pyramid so we can draw all over it. Okay? And our drawing is going to get a little bit messy, so try to follow me. I want to find the surface area of this pyramid. Let's see what it tells us. It tells me that the pyramid is 147 meters tall. Where would that 147 go, Hunter? Okay, so it's going straight down the middle of the pyramid. Okay, straight down the middle of the pyramid is my 147 meters. Okay, so that this makes a right angle. Maybe I should use a different color. Let's see. So this here at a right angle is 147. Okay. It also told us back in the problem that it stands on a square base that's 231 meters on each side. So let's go ahead and make it big again. And I'm going to mark in 231 meters on all sides. So this is a square pyramid, which means these are all 231. I think just marking those two is good enough. But really, all the way around, they all be 231. So when I want the surface area, what shapes am I dealing with here? What shapes am I having to find the area of? Triangles. Okay, so we have 4 triangles and a square. Are all of the triangles the same? That makes our life a little easier, right? That we can find the area of just one of them and then it's the same all the way around. Okay, the problem is, if I were to ask you to find the area of this triangle right now, what are you missing? Matt? Okay, we need the slant height of the pyramid because the slant height is really the height of the triangle. Okay, so we really need this. Okay, so that this makes a right angle here. Can you see that that would be the height of the triangle?
Yeah.
And if I had that, I could do base times height and then divide by 2 to get the area of that triangle. Okay? How am I going to get that red line? Everybody look at it and think for a minute. How could I get that red line? Go ahead, Hunter.
You would divide 231 in half, and then you would get the distance from the middle to the side, and then you would find the angle.
Okay, so you're talking about this,
Yeah.
right? And when I draw that black line in, look at what beautiful thing I have sitting there for me. Okay, do you see it? All right, so how long is that black line? Hunter just said it a second ago, but it'd be half of 231, right? Because this whole thing is 231, which means all the way across here would be 231. So, yep, 115.5. It's half of 231, okay? And then I've got 147 going up and down, and then this is like my C value if I'm going to do Pythagorean theorem, okay? So the first thing I'm going to do, and you can squeeze this in however you want to, but the first thing I'm going to do is Pythag so that I can find the length of that red line, so I can find that slant height, okay? So I'm going to do 115.5 squared. You ready with calculators? I'm going to need your help. Plus 147 squared. Hold on just a second. Equals C squared. Everyone understand where that setup came from? So 115.5 squared plus 147 squared. Go ahead, Hunter. What does that whole thing equal on the left?
34,949.25.
34. Thank you.
And then that square root of it is
Yep, so then we're going to take a square root. What do you get?
186.95.
I'm gonna go ahead and let you just round that to 187, just to make our problem work a little nicer. I am sure that it is not exactly 231 meters on the base. I'm sure that there's some rounding going on there too. So let's go ahead and make that C value 187. Okay. Now talk to me about what to do. Jake.
You would do 231 187, right?
Yep.
By 2, multiply that by 4.
Perfect. So 231 times 187 divided by 2.
21,598.
Okay, hold on. 21,000.
598.5.
Okay, and that's after being divided by 2?
Yeah.
Okay. So that's the area of one triangle. Okay, one of those triangles is that many square meters. Think about how big that is. It's huge. And I have 4 of those, right? So to get my total surface area, I'm going to switch here to, no, I just used blue. Let's use red. My total surface area is going to be 4 times that number. Does everyone understand why I'm doing 4 times it? Because I'd have 4 of those triangles. And now technically, I would bet that all we really care about is the lateral surface, right? The 4 triangles, because that's what's sticking up out of the ground. But because this said surface area, what else do I have to include? Okay, the square on the bottom, right? Okay. Which would be 231 times 231. Someone help me with that. 231 squared, basically.
53,364.
Okay. So the area of my square on the bottom is 53,361. Let's add that on there. For a grand total of, you have it? Or are you just making it up?
Yes, or no,
Good.
139,000.
Yeah.
55.
Square meters. Okay. How'd you do with that one? Yeah, go ahead, Jake.
Question. I kind of got lost for a second.
Okay.
Wait, so we got the 4 triangles.
Yep.
Which is 21,598 per
Yep.
triangle, and then for the base you would do 115 squared pi.
We did, for the area of the base, because the base is a square, let me pull the picture back on there.
Circle.
We did 231 times 231. That's what this was down here. You're right. I got a little unorganized at the end there, but yeah. So 231 times 231 gave us the base of the square. This 21,598. That was the area of one triangle, and then we multiplied by 4 because there are 4 of them going around the outside. Bryce?
Like, I guess I'm confused when we got the 115.5.
Oh, okay. The 115.5 came from that black line there. Whoops, where's my little pointer? This black line here. Do you see that it's half of the total distance across the base? Okay, so I took that 231 and cut it in half. Okay, if I were to draw in the rest of it, like going this way, then that whole distance would be 231. But I cut it in half so I could do Pythag. Follow that? Okay. Okay, let's talk about cones, okay? Because cones do not fold out into a nice net. Everyone able to find where we're at? Because this is like where you had to switch from one page to the other. I have this page in there somewhere. Okay. Everything we've done so far, we have taken the shape and laid it out flat and thought about like, oh, this is a rectangle, a triangle, and all these other shapes that we're familiar with. Okay? When you unfold a cone, you get this weird thing. Okay? And I know on this one it looks almost like a semicircle. It's not always a semicircle, depending on how sharp the angle is of your cone. Okay? It's this weird piece of a circle that doesn't really have a good shape to it for us to find area. So with cones, we really have no choice but to use a formula. Okay, there is a formula for cones. You know, I tried looking up, I was going to show just a quick little like video animation of where the formula comes from. You have to know calculus to understand where this formula comes from. I'm not joking, like actual calculus. Okay? So I decided that I would just cut you some slack and just show you the formula. Okay? So for a cone, here's what I want you to write down someplace right around here. Lateral area of a cone is equal to pi times the radius times the slant height. So we always use L for slant height. I'm not sure why, but so slant height would be like this here, okay? Like the slanted height up to the top of the cone. So lateral area is pi times radius times slant height, okay? So I'm just going to recopy that down here because it's asking me to find lateral area. So pi times radius times slant height. And then I'm going to take my numbers from the problem and put those on here too. So my cone has a radius of 10. That means this down here is 10. And a slant height of 13. Okay, so what am I going to do? So pi times my radius, which is 10, times my slant height, which is 13.
108.4.
Okay, and I guess that'd just be square units because I didn't give any units on that. So then think about what we have to include if we want the surface area. We just found the lateral area, okay, which would basically be this whole outside surface of the cone. But for surface area, we also want to include the circle at the bottom, okay? And area of that circle, area of any circle, is going to be pi r squared. So in this particular circle, it would be pi times 10 squared, because 10 is my radius, which gives me a total of 314 square units from the circle. Okay? So now to get the total surface area, that was just the area of the circle, total surface area, I want to take that lateral area that I got before, the 408.4, and add to it the area of my circle, which is 314. And let's see, I believe I end up with a total of 722.4. Whoops, 0.4 square units for my surface area. So again, surface area is just going to be the lateral area plus the area of the base. Okay. Okay, so our next example here, let me get rid of that for a second, gives us a cone with a radius of 4.2, and this time it tells us what the surface area is. So let's go ahead and fill those numbers in. My radius is 4.2. And I know the total surface area is 187.4. And what I'm looking for this time is the slant height. I need to solve for the slant height. Okay, so remember back when we did area, and we had these problems where it would tell you what the area was and then ask you what is the height or something along those lines. I told you to always set up the formula first, fill in whatever you know, and then solve for whatever's missing. So let's think about how we would find surface area of this cone. We would do pi times the radius. Let me just actually back up a little bit on that. In general, surface area is going to be the lateral area plus the base, right? And only one base because this is a cone. Don't stress too much about that like as a formula, but just sort of so you see where I'm going with this, is I'm going to set this up so that I have the lateral area and then I add on the base. Okay, so I would do pi times the radius, which is 4.2, times the slant height, which I don't know what that is yet, so I'm just going to call that L. That is my lateral area. And then I'm going to add the base, the area of the base. Area of the base, well, it's a circle, so it would be pi times radius squared, and the radius is, 4.2 squared. Sorry, that got a little messy. So that there is the area of the base. Okay, I'm going to go ahead and do the pieces that I'm able to do. So I can calculate pi times 4.2. And I get 13.19. And that's going to be multiplied by that slant height. Plus, this whole thing I should be able to type in. So let's see, pi times 4.2 squared comes out to be 55.42. And then that should equal my total surface area, which we know is 187.4. Okay, so I filled in the information that I knew. This is the information that I'm trying to find, and now I'm just going to solve for it. So from here, I would subtract the 55.42 from each side. That's going to leave me with 13.19 L equals gosh, almost exactly 132. It's 131.98. Okay, divide by 13.9. Divide by 13.9. And that's going to give me my slant height of about 9.5. Now, you may have come out with something slightly different if you rounded some of those numbers differently along the way, but final answer should be right around 9.5 for your slant height. And if you wanted to check that, you could go back and calculate the surface area yourself using this as the slant height, and it should come right out to close to 187.4. All right, one more example to get through. Okay, guys, I know you have this one last example on there. This one is kind of complicated, probably more complicated than what's in your assignment for tonight. I think what I'm going to do is I'm going to have you skip this one for now. And if we need to, we'll come back and do this one together as a class tomorrow. I just want to make sure that you have enough time to get started on your assignment. And like I said, I think this problem is going to confuse you more than it's going to help you. So hold off on that until the day I'm back in class with you. We'll do that together then. You can go ahead and get started on your assignment, which is from section 10.2. It is posted in the back of the room. It's also listed in your notes packet.